My name's Mark Gibbons. I'm National Manager for CHP at Baxi Heating. So we're going to go through the future of heating and hot water in commercial buildings as it currently stands. Obviously, the legislation is changing all the time, what with the advent of heat pumps, hydrogen discussion, all this type of thing. So we're going to go through a few things, and then we're also going to look at some examples of heat networks. So in terms of Baxi, the Baxi family, most of you, I guess, would know, we've got the boiler ranges, Potterton, Romea, Andrews water heaters, Heatray Sadia. All of these products are the ones that we've sold through BSS over many years, and we're also part of BDR Thermea, which not a lot of people know, but they're one of the top in the world for heating and hot water systems. We're represented over 100 countries, and we have about 2,000 employees on a €2 billion turnover per year. So we're well versed in the changing trends of what heating and hot water is all about. Now, our blend to net zero, over many years, we've been collaborating with BSS on a number of schemes. On my particular portion of the company, the CHP, I think I counted the other day, we've done 340 jobs with BSS over the years, which is a fair amount. And that's not just the CHP, that's the boilers, cylinders, sometimes water heaters as preheat. So there's a number of packages that we've supplied through yourselves, along with our PPS, or now Baxi Package Solutions. Some of it has gone through BSS in partnership with yourselves. So it's not only just about the product, it's about the backup and the support service that we provide, working in conjunction with yourselves. Now, all of these solutions can be gained through BSS, and over many years, you've seen these products. So we've got anything from hot water heaters, Andrews water heaters as they are, the CHP, which acts as preheat in most cases to water heating or hot water systems. Then utility cupboards through our package plant. And we've got several key accounts which actually marry up with yourselves. So some of those jobs go through yourselves as well. HIUs, and also lately now we've got the air source heat pumps coming on stream as well, which we'll talk about in a short while. Now, the blended approach to net zero. As a manufacturer of gas boilers, we've committed to changing the gas boilers to burn on low carbon fuels by 2025 onwards. So obviously the government are saying 2030 we should stop using fossil fuels. Who knows? I mean, at the end of the day, it's changing because the discussion's now gone on to hydrogen. So the hydrogen mix in natural gas will be uplifted to about 20%, which is what the grid is telling us. It's whether the government then put the funding in to get it sorted out, but it's crystal clear that we can't just keep burning gas. However, the shame about it all is, if you look at the way commercial buildings are designed, a lot of the time the plant is oversized for the U values in the building, so the heat losses don't match the fuel input. So we could actually reduce that, but the key point is, a lot of the time we don't educate the building user or the owner of the building to understand how they can reduce their energy costs, because a lot of the times you go in, and we quite see it regularly, where you've got a row of boilers, 300 or 400 kilowatts, and then you've got a little dinky CHP system sat down doing nothing, because all the boilers have been turned on manual and whacked up to 80 degrees. And a lot of the systems now aren't designed on 80-60 anymore. They're starting to come down to 70-50 and even 60-40, which then falls into the realms of the air source heat pumps. So as we move forward, 2030 onwards, the BEIS are saying that they are going to start putting hydrogen into natural gas to reduce the carbon emissions. The UK, as it currently stands, I understand, have a Norwegian partnership arrangement with bulk hydrogen, which is the green hydrogen. And that is due to start coming in around about 2030 to 2035. So we will see a change, but we're going to go on to the plant now that's being manufactured by companies like our own, where we're making the plant compatible with a certain portion of hydrogen. So over the years, we've gone from standard condensing boilers or non-condensing boilers. Then we got involved in biomass, which was another step, burning wood, of course, which created pollution. And then moving on, off-site became a big thing. So we then started putting package plants together, skids and all this type of arrangement, so that all the stuff was built off-site. And then when the guys got it onto site, it was literally take it apart, put it in, then rebuild it in a fraction of the time it would actually take to do a complete package plant room. Then also small footprint boilers, high outputs, the gas 220s, 300 kilowatt output in literally not much bigger than this stand. And that's the kind of power that the boilers have. And CHPs have been around for many years. Through BSS, we've been dealing with BSS for 13 years on delivering CHPs into packages. And also the large gas 320 type boilers, low water volume and very, very wide delta Ts as well. And then we're coming then onto air source heat pumps. All of the equipment that we now offer on boilers are 20% hydrogen certified, so that when the hydrogen does change, whether it's a boiler or the CHPs, they're all ready to go and work with hydrogen with very little modification. Literally just a tweak of the gas valve, and in the case of the CHPs, it's just a timing change. So the customer will not have to pay for extra upgrades on the boilers. And it's the same with the domestic. And in terms of the domestic boilers, we've currently got boilers running on 100% hydrogen, both in Leeds and in Newcastle. So we know they're working, and these are people living in properties with hydrogen. So we're getting feedback all the time on the performance of the boilers. But as far as commercial is concerned, we've got a bit of a leeway from the government on telling us when they're going to completely phase out gas on commercial buildings. But hydrogen certification, so moving forward, you've got at least 5 to 10 years on these type of boilers with the upgrade to certification for hydrogen. So your customers are well covered by the eventuality of increase in hydrogen. Now, from our company pledge, obviously we're pledging that all of our product will be used with low carbon fuels by 2030, and we'll phase out a lot of the carbon intensive product that we have. So some of the water heater systems will go because you can't get the efficiency of those any better. But in a large majority of cases, the diversity of our product range will increase because we'll have more and more heat pump ranges coming on. Plus we'll have an expansion of potential CHPs as well, because it's crystal clear that in the current climate, CHP is a benefit to a lot of customers, and it's all about cost. So the energy argument is one thing, but actually the environment might kind of take a little bit of a backward step, because the customers are using things like CHPs running on natural gas with a value of cost roughly 10 to 20 pence per kilowatt hour. But then we've got one customer who's being charged 72 pence per kilowatt hour for electric. So then the CHP sets off that cost. So it allows him to operate. And as the buildings are getting bigger and bigger, there's more heat demand. Yet in actual fact, you can actually go the opposite way and reduce the heat input to some of the buildings. So there's a major benefit on some of these technologies that will be getting bad press in some cases, but actually there's a major benefit to them. We are a company moving forward that value the people that we deal with and we work with and in our communities. So we're constantly looking at ways to look after the environment. So sustainability and recyclability is key within our company ethos at the present time. And this journey goes on right up to 2050. So the key points for us is 2025, where we'll start cutting back on fossil fuel burning appliances only. And in 2030, the potential for all fossil fuel burning equipment to be stopped in commercial buildings. Of course, we do the domestic as well. So when it comes to 2033, then there's going to be a cutback in domestic and commercial. And then by 2050, the UK government's net zero carbon will be such that we will be hopefully developing hydrogen boilers alongside air source heat pumps. So that's really the view as it stands at the moment. Who knows if that'll ever change? Around about 2040, there's a review of CHPs, because at the present time, a large majority of heat network systems will have a CHP attached to them, and they're looking at the validity of CHPs. Well, CHPs can be quite easily adapted to run on several fuels. So as we reduce the carbon emissions of the fuels that we use today, then the CHPs will carry on running. So 2040, 2050, we may still see a lot of CHPs on the system. To give you an idea, at the moment, there's about 3,700 sites in the UK that have CHP units. The grid network can't afford to take those offline, because the grid would collapse. So there is a major benefit at keeping CHPs online. Now, obviously the heat network is a big thing at the present time. So there's two types. There's the communal network system, which basically relates to just a single building. So you have your plant room either in the building or outside. That would then be feeding a distribution system into HIUs for each apartment, or whether it be offices or whatever it might be. So that's the kind of communal system. The big one, the heat networks, is obviously where you've got a centralised plant room feeding several sites off of a district heating main effectively. Because in the 70s and 80s, when I started dealing with them, it was all heat networks. Then that kind of district system kind of failed because of the poor installation. Now it's come back to that, and I think the techniques for installation of piping systems are getting far superior to what they used to be. So this is your typical district network system. So you've got your centralised plant room on the end there being fed by the grid for electricity. And then you have an underground system of heating mains supplying different types of buildings around a given area. And I don't know if you're aware of it, but there's 14,000 heat network sites in the UK, and they supply in excess of 500,000 people. So they are an important part of our infrastructure, and these are growing and growing and growing. So as we then decarbonise, the idea behind the centralised plant room is you've only got one source of emissions. And of course, there is a big thing about central cities as well with regards to NOx. NOx is a massive issue for a lot of people nowadays because of pollution, of course. So that's really driving this thought to actually getting rid of a lot of the appliances that create pollution. So with that in mind, you'll have several sites within that network. And this particular one, this is a school up in Glasgow. And this was done back in 2013-14. And the engineer of the time wanted to know how he could reduce his carbon emissions off his site. And what he ended up doing was employing a ground source heat pump. In actual fact, what they did, they sunk the boreholes, which are this flow and return piping system, and connected to that was 5 CHPs. And the job of the CHP was to be brought into use when the building required extra heat that the ground source heat pump couldn't provide. The CHP would then be diverted to supply the heating and hot water in the building. Bearing in mind all the time these CHPs are running, they're producing electric. And then in downtimes, when the CHPs weren't needed in the building, the ground source heat pumps would be brought in, but the heat from the CHPs would then be dumped into the borehole. So when they did the initial calculation on the geology of this particular site, they reckon they had about 15 years of heat in the ground before they then had to take those boreholes up and put them somewhere else. But what they've got is they've got a constant drive from the CHP to create the heat in the ground, which then stabilises the geology. So you'll always have a heat source for the ground source to keep on going. And to give you an idea, the blue curve at the bottom is the one at Notre Dame School, and that's the energy reduction when compared to several other schools of an equivalent size. So the ground source heat pump with reduced CO emissions and the heat and the CHPs providing all this heat into the ground, you've got a constant source of heat between 65 and 80 degrees, which then allows the heat pump to work at optimum performance. And in that particular equation, year on year since 2014, the average savings that Glasgow City Council made on this particular scheme was in excess of £65,000 a year in energy cost savings. So as far as the council is concerned, it was nothing they've ever tried before, and there's now another 3 schools on that type of system, which are now making them a lot of money in terms of the savings for the school, which they then play all that back into the school curriculum. And moving on to air source heat pumps, everything is about air source heat pumps and electrification at the end of the day nowadays. We've got this is a school with a heat pump on, and basically this is a bivalent system. So we've got the heat pump feeding into a water heater and boilers, and the heat pump is purely there just to give it some preheat. At certain times of the day, if the temperature drops below 7 degrees, the BMS will then kick the heat pump off. Then the school will then start to burn the boilers just to lift up the extra 10 or 15 degrees that's required to make it hot and comfortable for the school children. Also, the hot water system doesn't need to be worked that hard because the air source heat pump is giving 55. So the hot water system only needs 15, 20 degrees at the most to get it up to temperature. And as we move forward on stand 13, we've got our heat pump there, which is the new range. The one we've got out there is an R290, and we have the propane. So the output temperatures of those are going to be approaching mid 70 degrees in most temperatures. So that's the presentation. So if there's any questions.
Just wondered, what's your thought on the hydrogen network, and how ready that's going to be and by when? Because that's going to be the challenge around. You said around 20% of hydrogen, but actually there's an awful lot of work that's needed, isn't there, to get the hydrogen network ready?
Yeah, it's down really to BEIS, who are dealing with the grid operators. The gas companies that we deal with, they're all saying that hydrogen's going to come. Getting it into the system is not so bad. What they've got to do is check the infrastructure, because of course the molecules in hydrogen are slightly different to the natural gas. So therefore some of the materials might have to be changed. So your polyethylenes generally aren't too bad, but the medium pressure pipework system might have to change. Also, of course, hydrogen is slightly more corrosive, so some of the mild steel mains might have to be coated. But the idea behind it is that they know they've got to do it. It's whether they're going to get the money from the government, but it's the government really that are pushing the hydrogen argument. So sometime down the line, they're going to have to start looking at how they can satisfy that particular need, because it's crystal clear. It's okay putting all these heat pumps on the system, and I was talking with a colleague of ours earlier on, and a large majority of DNOs cannot cope with extra heat pumps on the system. The capacity of the grid will not allow it to happen. London Fire Brigade in London are approaching UKPN over all their sites to go heat pumps. The problem is UKPN can't provide them with the electricity to provide them all, especially when they have their fire tenders being charged up and all the rest of it. So you're getting electric vehicle charging on top of the heat pumps, and then the grid is getting smaller and smaller. So in some cases we've got 20-30% of the grid now is coal, because we've gone back to coal because of the shortage of gas. And then we've got a large majority of renewables. However, some of the battery farms that are being used to store electricity, once they discharge, you can't charge them up for about a week, because the batteries have to cool right down before they can actually put more current in them. So therefore you're missing a portion of the grid. And this is going to cause a great deal of problems. So though the heat pumps obviously are the chosen choice, it's about the communication at the design stage, because if a designer forgets to mention that the DNOs need to be involved in this process, it could be that the job will get stopped. And one particular council we did a presentation to, they applied for 20 schools to be connected with heat pumps, and we weren't talking big heat pumps here, we're talking 40, 50 kilowatt max. But 18 of those were rejected because the network is in such a state that the nearest substations to the schools that they were asking for were so far away, they never had anywhere to get the supply from. So it's a big question that the grid networks have got to actually supply. The gas grid is slightly more complex, but the electrical side is going to be a balancing act between electric vehicles and heat pumps.
Do you think there'll be an increase in district heating systems?
Well, the heat networks are going to have to increase, because the decarbonisation process can't happen without reducing the amount of plant that's used. So again, heat networks are fine, but then, for instance, one particular builder's got planning for 1,000 houses just outside York. Now with that, he's got to have a whole complete system put in. Now that becomes a complex situation when they're trying to expand the network from the current size to take up for another 1,000 houses. Now in some areas, the DNOs are actually looking at providing all housing estates with a three-phase supply. At the moment, the average house will have a single-phase supply. But what they're looking at doing, if they supply a three-phase to a house, they can break one phase off to do the normal electrics in a property. They can then break one off to do electrical vehicle charging, then they can use the other phase to power heat pumps up. Obviously, with a high voltage network, you haven't got the intricacies and the problems you've got with a low voltage system where the step up, step down transformers at night time go crazy because everybody's finished watching Coronation Street, then go and get a tea, so the kettles go on, and then EastEnders comes on, or whichever way it goes. And of course then these step up, step down transformers are constantly going on and off. And this is why you get flickering at night time in your properties, your lights may dim slightly or whatever. And it's these step up, step down transformers are actually struggling. So the heat network argument is a lot of electricity is needed to power up these centralised plant rooms. So again, it's a discussion that the DNOs are having to answer to actually give us a solution in construction for us to be able to build. So it's unfortunately, the answers to these questions, they're not 2-minute answers because the whole system is so complex. And the other thing that we also forget, with all these systems, complicated BMS systems are required. And so when you're putting in heat pumps and standard gas boilers or CHPs or whatever, the BMS has to be able to balance out the bivalent type system because one can often cancel out the other one. And that's when it all goes wrong, and that becomes hellishly costly for the owners. So it's okay to build it, it's okay to deliver it to the end user. The point is that we don't often follow up and explain how to use the building properly to the end user, and then they get disillusioned with the product that's in it. And then you get failures. Heat pumps fail, boilers fail, and it's all down to the end users not knowing how to use their buildings properly, which causes the issue. But it will increase. I mean, like I say, there's 14,000 network systems around the UK, and that 500,000 people that are being supplied by these networks is only going to go in an increase. There's big systems all over the place. One of the biggest ones is Truro, 2,000 houses on a district network, been there for 40 years, still working away. And High Wycombe's having another one, that's going to something like 1,000 houses. The one in York that they're applying for, another 1,000 houses. So as we build all these properties, and that's bearing in mind this is domestic, when you start looking at commercial, that becomes another big thing because it's saturation point on saturation point, and that's where the issue is going to be. Cheers, everybody. Thank you very much. Thank you.